Welcome to Web Handling. My name is Dave Royso. I am super excited to continue our new mini-series based on our new must-have Web Handling Handbook. In this clip, we introduce a section on rollers, which are the building blocks of your machine. Here we list the most commonly abused do's and don'ts of rollers, as well as resources for more information. I know your time is precious, so let's get started. "25 years ago, I gave a paper at several conferences entitled The 10 Commandments of Web Machine Design. As a consequence, the director of the Web Handling Research Center and my former boss, Carl Reed, called me Moses. To this day, I am not sure whether he meant it as a compliment or as a critique of my arrogance, or both. However, it was the foundation of a book-length discussion in my Mechanics of Rollers book that was published in 1996 by Tappy Press. It was a bestseller for Tappy, and quite incredibly, is still in publication today, a quarter of a century later. The 10 Commandments are listed here for reference. Each commandment deserves an article, if not a whole chapter, to discuss, and we will show how to get those details shortly. Many people like to be rule breakers. I am one of those people. Many people like to be the exception, hoping that they won't be caught, or if they do, that the punishment will be mild and worth the risk. However, in the case of web handling, it can be sometimes difficult to predict the consequence of breaking the rules. Some of this is due to the complexities that we are not always 100% sure of. However, some of this is also due to the general nature of general rules. However, we can sometimes make general conclusions about these general rules. At the least risky end, breaking the first commandment about using the fewest rollers may have mild consequences. It will merely increase the initial and ongoing costs. At the more debilitating end, excessive deflection can mean anything from permanent handicaps for the machine or even the death of a machine, meaning that it's not an economically viable process. Consequently, most of us should be quite conservative at the design stages and with ongoing maintenance throughout the useful life of a machine. My first job out of college was as a winder designer for the oldest and arguably most proficient of the machine builders, the Beloit Corporation. The consequences of error in the paper industry are extreme. $20,000 per hour for lost production, to millions of dollars per year for many waste and delay items, to tens of millions of dollars for upgrades to fix design oversight. This strict upbringing has left me with a lifelong impression on how to handle web machine design decisions, quite conservatively. In short, an ounce of studied design prevention is worth a pound of cure at the customer's plant. To complicate matters, many of the commandments have a range that is peculiar to a specific application. The tolerances for paper are much tighter than for nonwovens, rubber, or tissue. Thin foil requires tighter standards still. Still, within a specific application, there is a range of cost-benefit within which you must make a choice based on your tolerance for risk. If you align too much, for example, you will increase the initial and ongoing costs. If you align too little, for example, you will increase waste, delay, and/or customer complaints. So, there is an economic optimum amount of alignment or any other initial or ongoing costs. This is a topic I've written on and taught much upon, so we don't need to cover that here. What I would like to do is to warn management and maintenance people the following: that you will overvalue things that are readily seen and undervalue things that are hard to see. By that I mean, as just one example, roller maintenance costs are readily seen. However, the increase in wrinkling and customer complaints due to a less than economically optimum roller maintenance will be much harder to see. As a consequence, you will undershoot the economic optimum for most day-to-day maintenance choices. So, the devil is, as they say, in the details. The mechanistic details are well understood and well covered. We have chapter-length discussions of roller alignment and its effect on path control and wrinkling as just one example. Here are just a fraction of the details we would expect designers in particular to know about. However, maintenance and troubleshooters should also have a solid command of the same subject matter. I hope you have enjoyed this introduction to the building blocks of your machine. Rollers. If you want to learn more, there are many resources, actually hundreds of articles on the subject, as you can find doing a Roysum Library database search. However, let me suggest a much quicker and easier way to learn rollers, and that is in 3 modules of my award-winning and trademarked Web 101 class that has been taken by 5,000 students just like you. In a few short hours, you will learn most of the key concepts you need to know about web machine design, maintenance, and troubleshooting. This course is available in the plant, in public venues, as well as video-on-demand training through AIMCAL, APITA, and TAPI. Finally, that and much more can be found in 100 pages of the Web Handling Handbook. However, don't be intimidated because each and every chapter is written to include everyday troubleshooting techniques for everyone, whether you be a lead operator or a product process designer. Thank you so very much for joining me in this mini-series showcasing some of the crown jewels of our new book. Stay tuned for the next clips where we will introduce more must-know topics from our new must-have book. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.